Uh, Good afternoon, everyone. I'm Namrata Bandekar, and this talk is going to be more of an introductory talk on how you can get started with video processing in your Android apps. So a bit about me to start off with. I am an iOS engineer at Oanda, but I'm also a part of the Android tutorial team at ravenderlic.com, which is a mobile development tutorial blog. And this is my 3-year-old puppy, Ginger. She looks really innocent, but she's quite a diva. So let's start with the talk. What do I mean by video processing? For this talk, I will be referring to video processing in the context of video editing. So things like scaling, cropping, trimming, or overlaying data on a video. And the input can be either video files or video streams. Where do we see video processing being used in mobile apps? A lot of popular social media apps like Snapchat, which is totally video-based. Instagram uses video as well. And we have Vine, which was unfortunately shut down earlier this year. Which was mainly a video hosting service. What were the common features in these apps with respect to video editing? A lot of these apps have special effects that you can apply on videos, like filters, and you can also put text or images on top of the videos. Some of the apps like Vine support merging different videos together into a single video. And then quite a few like Instagram supports cropping and trimming of the video, even adjusting the tilt and stuff like that. So back to my story. In early 2015, I started working at StageName, which was a 3-person startup at that time, and I joined as an Android developer. And they had this product called WeatherGIF, and as the name suggests, it was basically a feed of weather data, and the screenshot shows how the app looked like. It was a feed of GIFs with the weather information on top of it. And I mentioned it's GIFs, but in the app, I was actually using videos and playing them in a loop. So what was the feature list that I needed to build for the Android Weather GIF app? This is basically how the app looked like. So I needed to build out a feed of videos that would play in a loop with weather data that could be overlaid. And then the users could also change the GIF associated with the weather data and share out their custom weather GIF to their friends on social media platforms like Instagram. These videos weren't really 1:1 aspect ratio and of this scale. So I also had to scale and crop the videos. And when I share it on Instagram and many other apps require that your video be a certain minimum length. A lot of the GIFs are, and the minimum length was 3 seconds, and a lot of the GIFs that I was using were less than 3 seconds. So I also had to loop the videos. So when I joined as an Android developer. The iOS Weather GIF app was already done. And Apple actually provides a really great library called AV Foundation, which has a rich set of features for video editing. So that meant that all of the video editing had to be done on device for my Android app too, because there was no backend support for this. This was good in a way, because this meant that the app would use less bandwidth. It would be faster and independent of the network, so people could use it while traveling in the subway or something like that. So I started looking for what kind of native support do we have on Android. And I came across a few promising APIs. One of them is the media codec class, which, as the name suggests, lets you encode and decode videos. Then there's the media extractor, which lets you take the audio out independently of the video, so basically demuxing the video. And then the media muxer class, which lets you put the audio and video back together. So this looked promising, but as I went deeper into it, I only saw that there were these classes, and there was literally no support for any of the features that I wanted, like cropping and scaling and overlaying data on the video. And this was my reaction at the time. So I started looking for what other libraries I could use on Android to implement this. And I came across a few, like GStreamer, which is a pretty well-known video processing library, but it is far too complex and too large to be included in your Android app. And then I discovered FFmpeg. Just a show of hands here, how many of you have heard of FFmpeg? Okay, so quite a few people have heard about it. It's been around for a while, and it's a popular open source library for anything related to video. Why did I choose FFmpeg for my app? As I mentioned, it supports all video processing tasks that you can imagine. It's actually known as the Swiss Army knife for all things video related. It also supports filters, like the ones you see in Instagram, so complex filters like blurring, as well as the things I needed to do, like cropping and scaling, are also known as filters in FFmpeg. And it even supports adding subtitles to your video. So I started looking at how I can use FFmpeg on Android in my Android app. And I found two ways to do this. The first technique is to build it as an executable and then run it inside your Android apps process, and then access it using the command line. And the second way is to build it as a shared object library or a .so file and use the Java native interface to interface with the FFmpeg executable. So I decided to look at building it as a FFmpeg executable because of a lot of reasons, like time constraints, and this was way faster than going the .so route. So let's go over the technique that I followed to build this executable. I was using a MacBook, and I discovered that I had to install a ton of dependencies, and I'm pretty sure even for Linux or Windows you would have to install all of these. So I had to install AutoTool packages like AutoConf, which is used to automatically configure your native source code. I also had to install AutoMake, which is used to automatically generate make files, and libtool, which is used for creating portable compile libraries. So let's look at how you can get started with building the executable. The first step is to download the NDK, and then you have to download the FFmpeg source code from their repository. And then you put you also download some libraries like YASM, which is an assembler for x86, which you will need to compile the code for x86 architectures. And FFmpeg doesn't really support encoding for some of the video formats, so you might want to download libraries like libvpx, which is basically for the VP8 codec. And then you put all of the code that you downloaded, the FFmpeg source code and the libraries that you downloaded under the NDK sources folder, as shown here in the picture. Notice that there's also the STL libraries there and the Android libraries. That comes with your NDK, by the way. So the next step is to configure your FFmpeg executable so that you can control the features that it has. And this is an example of how the configure script looks like. It is kind of intimidating, but we are going to go into detail for each section of this. You can use FFmpeg on a lot of different platforms and architectures. So you'll notice that the first thing that I do in the configure script is define the target OS, which is Linux in our case, and also define the architecture for which I'm compiling, which would be either ARM or x86. And then we also have to specify the directory in which your NDK is, using the sysroot flag. And the compiler uses this path to search for headers to compile the native code. The next thing you would see is the different enable and disable flags in the configure script. So FFmpeg is actually, it consists of a bunch of different libraries. So what I'm doing in this configure script here is just basically enabling and disabling different libraries. So when I do enable decoders and enable encoders, I am enabling the libav codec library. And then the enable filters enables the libav filter library, which lets me do all the video processing tasks like cropping and scaling. The other thing to note is you can also enable the decoder or encoder for specific formats. So you don't have to include all of the different formats. So for here example, I'm using enable decoder for MPEG-4. And in a similar way, you can also disable the decoders. FFmpeg supports a lot of different formats, but it does not support encoding H.264, and H.264 is very widely used. So if you wanted this feature to be in your FFmpeg executable, you would need to download another library which supports that, and libx264 is one such library. The way you integrate it with your FFmpeg is by downloading the libx264 code, putting it in the NDK sources folder too, and then putting this flag in your configure script. One thing to note here, though, is libx264 is distributed under the GPL license. So after I'm done compiling, I just have to run make, and it's going to create the FFmpeg executable. But you actually need a lot of patience for this, because it takes at least 20 minutes for each architecture to compile the code, if you're including a lot of different features in your FFmpeg. And I felt like this XKCD comic described the process quite well. Instead of maybe sword fighting, I would replace it with Nerf guns. So after you compile, you're gonna get an exe file, which will be in under the bin folder in your NDK. And then you can just copy it to the raw folder in your app, which is under the resources directory. And then you're going to write some Java wrapper classes to actually pass commands to this executable file. But before that, you also need to make sure that this file can be executed inside your Android apps process. So you need to change permissions on the file. So the way to go about doing this is to first copy the FFmpeg executable file out of the raw folder into the app's bin directory. So over here, I define the bin directory path. And then you use the chmod command and change the permissions to 755. So the next step is to pass commands to your FFmpeg. And the way to go about doing this is to use the process builder class in your Android app. The process builder can be instantiated by passing the list of commands to its constructor. And also, you need to specify the directory in which your executable, FFmpeg executable is stored. So that would be the bin directory here. And then you take the process builder object and you call the start method, which returns you the process object. So this starts the process of sending those commands. So it's basically executing those commands on FFmpeg. And then you can, in your thread, you can wait for the process to finish, and it returns you the exit value. This is basically executing like any other shell process. So the exit value will be 0 if it's successful. And if it's non-zero, that means your process terminated with an error. And you can look up the shell process error codes to see what went wrong. You can also get the output of the process using the output stream and error stream of the process class. So FFmpeg takes in commands using something called as a filter chain. And as I mentioned before, the different tasks, video editing tasks like cropping, scaling, and overlaying are all known as filters. And when you chain them together like this here, it's just called the filter chain. And here I'm just passing in the command line commands here. So -I is the input file, and the -vf is for the filter chain. And then I specify the filter chain. I also specify the output path of my processed video. So I ran this code and tried sharing the GIF, and what I found was it was taking at least 15 to 20 seconds to process every single GIF every time I ran it. And I kind of felt like this, how the slot would do things in the movie Zootopia, if anyone of you have seen it. The major overhead was from spawning a new process every time the user would share. And the app took a really big performance hit because of this. So I decided to explore the second way of implementing this, that is to build FFmpeg as a shared object library. So when I did this, I was still using FFmpeg in a command line style. And I was using my JNI code to call the main, FFmpeg's main. So the setup for this process is similar to the executable process. You have to download all the source code and put it under the NDK sources folder. And the other thing you need to do is put your JNI library project code in the same directory as your NDK. JNI is the Java native interface, and you can use this to write wrapper classes it could be C++ or C code to access the methods in the native library code of FFmpeg. The next step was to make this android.mk makefile. This file is basically defined per library. So I had to make an android.mk file for my GNI library, wrapper library, and I had to make an android.mk file for the FFmpeg library. And as you can see, this file specifies a number of different environment variables which are used by the compiler. I specified the name of my library in the local_module, and its video kit here. And then I also specify the source files that need to be compiled for this library. So that's my videokit.c file and FFmpeg.SO file. And then I specify the shared libraries that this library is dependent on using the local shared libraries variable. The next step is also to create the application.mk file, which is another make file. And this one defines these properties for all the modules in your project. So it'll define these properties for the video kit library as well as the FFmpeg library. So you have to specify the ABI that you're using here. That would be either ARM or x86, and the NDK toolchain version, and the STL libraries that you would need to compile your code, the native code. And the last step is to place your C or C++ wrapper classes in your app's GNI folder. The other thing I forgot to mention is you have to also place the android.mk and application.mk files in the same folder. And then you run ndk build. It's going to also look at the same configure script that we used for the previous executable file technique. And it's going to produce these .so files. So once you get the .so file, you can put it under the GNI libs folder in your app under the architecture that you compiled it for. So you'll have to make different folders for each architecture. How do you use the .so file, or how do you access the .so file in your code? You basically have to write a Java wrapper class to load the library. And then you also have to define the native methods that are in your .so file using the private native keyword. So I'm just going to demo my app. So it's using the .so file now. This is something I did after the fact, after releasing the app, because it was so slow. So as you can see, I just went and shared that GIF there, and it's executing all of the commands, like cropping, scaling, overlaying, and in this case, also looping the video. And here you can see that it's created the video with the icon and the temperature text overlaid on top. So it took quite a while to do that, about 8 to 10 seconds still. And it was, I guess, just good enough to be put on the App Store. One thing I want to mention with FFmpeg is the licensing issue. It's distributed under the LGPL license, but some of the libraries that you might want to use are distributed under the GPL license, like libx264. FFmpeg has this really huge license compliance checklist on their website. It's about 20 points. I didn't include the whole thing here. But it's really, I would stress on following each and every point in this because it's all to satisfy legal requirements. And you'll notice that they even say you should not misspell FFmpeg. They require you to use 2 capital Fs followed by MPEG in small letters. I'm just going to talk about some of the items from that list, which are really important. So if you are using your app for commercial or proprietary use, you shouldn't include these flags in your configure script. This is basically going to, if you use enable non-free, for example, it's going to put your code under the GPL license. The other things to note are that FFmpeg can only be used as a dynamically linked library if you want to follow the LGPL. And then even if you're not modifying the FFmpeg source code, you're required to put whatever FFmpeg source code you used in your repository and make it public. And you also need to include the configure script that you used to compile your FFmpeg, and also put it in your repository. They also require you to mention that you're using FFmpeg on your website wherever you have a link to download your app. So this is an example from Yelp. They actually put this in their Google Play Store notes, and every time they release it, they have to include it in their notes. And you also have to put the license files in the directory in which you put your FFmpeg, so in your assets or raw folder. And this is again the example from Yelp. This is how their tree looks. So what are the advantages of using FFmpeg? It is modular. You can control the features that you want to include in it, and you can actually control the size of the executable or the library that you're going to build based on the enable and disable flags in your configure script. It supports a lot of different codecs and video formats. It doesn't support encoding, though, for a lot of video formats. It can handle a lot of different video processing tasks, so it's pretty versatile, like a Swiss Army knife. And it's been around for a while, so you'll find quite a bit of documentation on GitHub or Stack Overflow, if you like using that. What are the limitations of using FFmpeg? I found the license compliance checklist to be pretty tedious. But you have to do all of those things, so that is one. It was pretty slow, even for really small videos. Basically, I was just using GIFs, which have very low resolution as well as bitrate, and the size of the GIFs was also very small, like 300 by 300 pixels, and it was still taking 8 to 10 seconds. And if you want to include all of the features of FFmpeg in your library, say you're building a video editing app, then the library that you're going to build is going to be really large, about 30 megabytes in size. So I looked at other options that anyone could use if they didn't need features like cropping and scaling and overlaying. And I came across MP4 parser, which was a pretty lightweight Java library. What does MP4 parser support? It supports merging of multiple videos into a single video. It supports trimming a video to make it smaller in duration. It also supports muxing the audio and video into a single file and demuxing them. So this is an example of how you can use MP4 parser in your code, and this is just using the reactive version of MP4 parser. You'll see here that I am actually passing in the output file path, and then I'm concatenating a cropped version of the video with its full version. And then once it finishes doing that, it's just gonna get the callback here, or if it can't do that processing, it's going to get an error in the throwable, as a throwable. And it's a pretty easy to use API, as you can see. So let's look at a demo of how this library performs in Android apps. This is the original Big Bug Bunny video, which is a pretty standard video for any kind of video processing research. It's like a benchmark. And it's a 30-second long clip. And as you can see, the resolution is much higher than the GIFs that I was using in my Weather GIF app. And here, I just went ahead and ran that code that we just saw and shared it to Instagram. And you could see that it concatenated the clip with the whole video. And that was really fast. That took like less than 2 seconds probably for a video of this resolution and duration. There was some audio as well in that. I guess I needed to put my volume on high for that, but it basically concatenated the audio as well as video. So what are the advantages of using this library? It is available as a Java library, so you don't have to go through all of that complicated process of building the executable or the shared object library. And then it is really fast, as you saw. And it has a clean API. It's very lightweight. So if you wanted to make some modifications to the code, it's very well documented, and it's available on GitHub as well. And there are some samples they have to show how to use it. What are the limitations for the MP4 parser? It is limited in functionality. You can only merge, trim, mux, and demux the videos. It doesn't support any encoding or decoding. So basically, it's only for concatenating input videos which are of the same format. So they have to have the exact same resolution, bitrate, and encoding. So that concludes the talk, and these are the resources that I used for my demos. I'm just going to go over them quickly. So the first one here is the Guardian project, and it has a lot of well-documented steps on how to build your FFmpeg executable. And it also has a wrapper class, a Java wrapper class that you can use to pass commands to the executable. Then this is the Yelp repository. They also have a script. They actually have this one script that builds FFmpeg as an executable for all different architectures. So it's pretty easy to use as well. And then the third one is the video kit library, which I used to build the .so file. It doesn't have very great documentation, but you can always look into the code and see what he's doing. Then this is the link to the license compliance checklist, and I highly recommend you go and look at it if you're going to use FFmpeg in your app. And then finally, you have there's the MP4 parser repositories and the reactive version of it. And they also have some sample code in both these repositories on how to use it. And since my company is a supporting sponsor, and they are hiring, I just wanted to mention this, that you can apply, if you want to work at my company, they have offices in the US as well as Canada and Europe too. If you wanted to work there, you can go to jobs.oanda.com. And thanks for attending the talk. If you have any questions, this is a great time to ask them. Also, I want to mention I have some swag, so whoever asks questions gets the swag, and it's on a first-come, first-served basis, so okay.
I just, and I might have missed this,
Yeah.
RX FFMP, is that what it was? Saying it's React.
RX MP4 parser?
Yes.
Yes.
That's a React library, like Facebook React, or is that what you,
Okay, so I'm just going to repeat the question for the video. He asked me if the RX MP4 parser is a React Native library, like Facebook's React Native. It is actually a React Java library, so RX Java library.
Okay.
It's not the same as React Native. Okay. Yeah. Any other? Oh, I have to give you your swag. So I have a T-shirt, a stress ball, and a hat. One of the T-shirts is women's. So I only have 2 T-shirts. One is the women's large, and one is a men's medium, I believe. Yeah. Okay, so here you go. Any other questions? I have lots of swag. Anyone wants a hat? Okay.
Recommendations for like video compression. So like I know FFmpeg is like really slow with video compression. Media codec is fine, so you don't think that which perform better than media codec.
So you're saying that media codec is slow for some.
Yeah, compared to other platforms, it's kind of slow.
Right. So you could use FFmpeg for, it supports a lot of different codec formats for decoding and for encoding as well. It supports some, but you could use other third-party libraries like libvpx that I just mentioned.
But like FFmpeg is still like really slow. It's slower than like media codec. So I was just wondering if any other libraries.
No, I unfortunately didn't come across any others. Stressful. Okay, I'm just gonna throw. Sorry. Okay.
Do you see any good uses for the MP4 parser, like real world? I mean, I know you shared the video on Instagram, but you could have just shared it if they had the file on the phone. Like, any other good uses with it?
So the only things that it can do are trimming or like putting videos together or muxing and demuxing. So I mean, I don't really know which apps use it. Sorry? Okay, so there is an app. I didn't know about that, thanks. So Telegram uses MP4 parser, but I haven't really seen any other apps. I believe Snapchat and Instagram use their own code. Yeah.
MP4 parser
So.
only trim the sample indexes. You can't like if you want to trim in between sample indexes. It has to frame it.
Okay, so what do you want? Okay, I have a lot more hats here too. I should have said that before. I have like 3 more. Okay.
So given kind of the challenges, I guess, that you ran into with FFmpeg, I guess particularly in speed, is it still something that you would recommend as viable? Like if someone wanted to make an app that needs to do this video processing, do you think it's viable to pursue using FFmpeg, or would you recommend not?
I would say if you're using really low quality videos like I was, it is completely, like, it wasn't that bad, about 8 to 10 seconds. And that That demo recording was from a Nexus 6P phone. So yeah, it wasn't very noticeable, I would say. Which one?
Oh,
Yeah, because this is a lady shirt. So some women need to ask questions. So is that all the questions we have? Yes. Okay, great. Thank you.